one piece of code is running on this chip. That is a C program. And what that program does is it is listening to the sensor, is listening to the signal from the moisture sensor, and it is also switching on. It is switching on this relay to energize the pump. So this is a C program which runs on this. This is doing one more. This piece of code does one more thing, which is it sends what it is listening to another piece of code which is in the cloud. That's where all the calculations are made. So we are listening to the moisture sensor. What do we do with that signal? All the calculations happen in the cloud, and then it sends a message back saying, do this or do that. So then this will energize the relay and switch on the solenoid valve. So when we have a system like this with many moving parts and software in multiple places, it can consume a lot of time to debug. Here are some debugging tools that can help. So first of all, if we want to know how our little device here is doing, we can use what is called a serial monitor. So here's a C code that's running on the chip. It gets compiled and then published onto the chip, and then the chip keeps running it forever, right? Now if you want to know how the little chip is performing, you can embed messages in this code with serial print commands. So you'll see this code is peppered with serial print commands, serial.print, serial.print, serial.print. So anytime we see a serial print in this serial.print in this code, we know that it is reporting something that we can then see via the serial monitor. All right. So the kinds of things that are important to report for debugging is, first of all, remember the little chip is listening to a signal from the moisture sensor. Every time it gets a signal, we serial.print the moisture level, and so we can know if the moisture sensor is working and it is sending its data to the Node MCU chip. Now remember, this data gets sent to a platform in the cloud, and that does some analysis and sends a message back, and when it gets a message back, it takes some action. In this case, it releases the water, right? So another useful thing to keep in mind for debugging is anytime this is taking some action, this little chip is taking some action, we again serial.print that it received a command to take the action, and then it is indeed taking the action. Okay, so both when it has heard something, when it has received a message, and then when it has taken the action that was in the message, we just pepper the code with serial.print commands. We know at least that it is listening, it is sending messages, it is getting messages back, and it is able to take action. So this is this serial monitor is a big help in debugging. If the moisture sensor is broken, you will not see this reading here. If something is wrong with the moisture sensor and it is reporting less or more than you expected, you'll also see that here. When you want to calibrate, when you want to see what is the reading when it's wet, what is the reading when it's dry, you can also use the serial port for those purposes. So extremely useful, right? Okay. In the second part of this, we have used, as I said, the second piece of code resides in the cloud. This is a graphical programming language, which is JavaScript in the backend. But what it allows me to do is put little boxes in here, and each box does one and only one thing. And so I chain them together, and that is my code which runs in the cloud. So what is happening here is the very first box is this device reporting moisture to the cloud, right? And then here in the cloud, we are checking, is this moisture, what is this telling us? Is the moisture reading telling us that the soil is wet or the soil is dry? So as I showed you before, using the serial monitor, when the moisture sensor is dry, it will typically read like 430, even 500. When the soil moisture sensor is wet, it will read something like 230, even 300. So we picked a threshold of 330, and if the reading is greater than 330, then we say that the soil is dry, all right? When the soil is dry, we need to switch on the pump. But before we switch on the pump, we want to test one more thing. Is it going to rain that day? So we make a call to the weather service, just like making a phone call, except this is, in the software world, this is called an API call. So just like making a phone call, we make a call to the weather service, and the weather service sends back all of the weather data for the day. So the next step, obviously, is to check whether there is rain in the forecast. So we check in this line of code over here, we check whether anywhere in the forecast did it say rain. And if indeed